Hello, welcome to a new video. In this video, we are going to be discussing a very important foundational topic in any chemistry course. We are going to be talking about ionic, polyatomic, and covalent compounds. So let's start with our ionic compounds. So I want to just say, I always like to separate ionic and polyatomic ions into one category, and then you have your covalent compounds. So ionic compounds, that's a metal and a nonmetal. You're going to notice that electrons are transferred, and you're going to use ion charges. And some teachers prefer the crisscross method, but I'll teach you a different method as well. And there's usually no prefixes, which you will be seeing in our covalent compounds. Polyatomic, ionic. Now, these contain polyatomic ions. Now, you'll notice this instantly, and basically these polyatomic ions, they're just a group of atoms that act as one ion, and you may be required to memorize these for some chemistry courses. However, some also do give some of like the other, like there's a lot of polyatomic ions. You may have to memorize all, may not. Probably not. But yeah, it's important to memorize the main ones. Like we have our nitrate over here, and we have our hydroxide. So yeah, and you may need to use parentheses. Now parentheses are needed. Now the whole point of this is basically to neutralize your compounds, right? And for ionic and polyatomic. And to do this, sometimes you may need more than one polyatomic ion, more than one metal or non-metal, whatever. So when you need more than one polyatomic ion, then you are going to be needing to use parentheses. Now this is very important, and this is only for polyatomic ions. Now for our covalent compounds, to identify these, you're going to look for non-metal and non-metal, right? And electrons are going to be shared, and you're going to be using prefixes for naming. And there's no charges, so don't worry about charges here. It's often a lot simpler. Let's get right into it. And finally, this is just a general rule, a quick rule to know for all of these. You need to know that ionic, that's a metal and non-metal, and then covalent, as I mentioned, non-metal and non-metal. Metal and non-metal, non-metal, non-metal. Let's move right down. Now this is very important. This was my periodic table project, and go ahead, you guys can use this. And basically this is so important. You need to know some of these important things like your ion charges. You're going to need this for any of the things I'm going to be discussing in this video today. So you know that this is 1 plus, this is 2 plus, and then when you go down here, you have your 3 minus, 2 minus, 1 minus, and then your noble gases 0. Now, let's scroll down into the actual naming and writing formulas portion. So for naming, you're going to be given the formulas, and you're going to be asked to name them. So let's start with CaCl2, okay? So CaCl2, okay, let's use our acronym SPACE, okay? What type of compound is this? Now let's look here. We have a Ca, and then we have a Cl. So we have a calcium, and we have a chlorine. Let's go up here. Our Ca, that's our metal. And then we need a chlorine, right? That's going to be our non-metal. So what is this? Metal and non-metal? That's going to be ionic. So, okay, we've identified that's ionic. And looking at the periodic table, we know our charges. This is also like a mix, so of course writing the formulas and the names, so you sort of get familiar with it. So we have Ca2 plus and then Cl minus, and the whole purpose of this is to basically neutralize the compound, right? So if you have 2 plus here and you have 1 minus here, how are you going to get it so that 2 minus 2 is equal to 0? Well, I just told you the answer. You need a 2. And how do you get that 2? Well, you can get 2 Cl minus ions. So if you add a 2 there, only then will it be equal to 0. So that's how you write the formula. And for naming ionic compounds, it's pretty straightforward. You have calcium, and then for our non-metal, you end with an "ide." So instead of chlorine, you're going to do chloride, okay? And if you're using another example over here, if you have a polyatomic ion, you're just going to state whatever the polyatomic ion is. And then another example right over here, right? Oh, look, this is actually covalent now. We have a C and an O, and we discussed non-metal and non-metal equals covalent. So this is our covalent compound. So you're going to be using prefixes here, actually. So this is different naming rules. So you have one carbon. So you're not actually going to do monocarbon. That's often a big misconception. You don't do monocarbon. You're just going to write carbon, and then you're going to do dioxide, because how many oxygen atoms do we have? We have 2. So dioxide, that's covalent naming rules. Now let's do a deeper dive into writing formulas. This is often where students have a few difficulties. So let's say we're doing magnesium oxide, okay? I'm just going to zoom into magnesium oxide. So looking at the periodic table, what's the charge on magnesium and what's the charge on oxygen? Remember, the "ide" is just for the naming. Let's go up here and look. Magnesium, okay, that's the alkaline earth metal. That has a charge of 2+. And this is something you'll need to memorize, but it's often straightforward. Like, look, 1+, 2+. And then you have your 3 minus, 2 minus, 1 minus, and then 0. So 2+, right? And what was our non-metal? We have oxygen. So let's go back up here. Our oxygen, that has a charge of 2-. So let's go back down and let's just write what we learned. So we have Mg2+ and O2-. Oh wait, look at that. It already, the compound is already neutralized, because look, what's 2 minus 2? That's just 0. So we don't need to add another 2. For ionic compounds, you want to write it in the simplest possible way. So this is just going to be MgO. We did it. Now let's move to our next problem. Now we have potassium nitrate. Now, nitrate, you have to memorize this, maybe. That's NO3-. And looking at the periodic table, potassium is going to be 1+. And once again, you just have KNO3 because, look, what's 1 minus 1? That's just 0. Now, calcium carbonate, another polyatomic ion, same idea. Dinitrogen pentoxide. Now, these are super fun. These are going to be easy. So you just write your N for nitrogen, and then we know it's di, right? So that's 2. And then for oxygen, you just write a 5 because penta is 5. So these are basically all the possible questions you may get when writing names and formulas for ionic, polyatomic, and covalent compounds. And I have a few quick reminders and some of the common polyatomic ions on the bottom. And I just hope this video was helpful. Thank you and have a great day.